Technology.
Welcome back to Two Nobodies, everyone. Rupesh is here again. Got a wonderful guest to introduce you to. Before I do that, this is a topic that is going to be really cool. We've talked about technology disruption, we've talked about sustainability, and I think like the person that we're talking to today kind of blends those two. His name is Brendan Smith. I know Brendan from way back when I used to train this guy every Saturday, Sunday morning. He was the best, by the way. Brendan, welcome to Two Nobodies. Really glad to have you on the show, and just looking forward to catching up. It's been way too long, so thanks for joining me, man.
Thanks, Pesh. Yeah, really great to be here. Really grateful to be invited, and yeah, number one, looking forward to just catching up on a personal level, and I'm sure we could talk for 3 or 4 hours, but we probably only have a little less than that, so, you know, happy to dive in.
Yeah, that's awesome. I remember, man, those, I don't know if it was Saturday morning or Sunday, but
Sunday mornings.
Sunday morning, that's what I thought, and I would pull you in, I feel like it might have been 8 or 9 o'clock in the morning, and no one's at the gym on Sunday, especially at Waterloo. I mean, if no one's there, just me and you, but you came every single time. Like, what I loved about you was your discipline. Yeah, and I don't remember in the early years, whether you started or not, but still, you put in the work, you put in the grind, and like, I'm sure that's translated over your work, but like, tell me about, I don't know if did you actually really enjoy the training at the time, or was that something that you're...
Yeah, I mean, sports has always been, you know, until very recently, I would say, a pretty central part of my life, you know, not just in terms of staying in shape, staying focused, but just really kind of being a guiding principle and sort of a learning factor behind how I kind of conduct myself elsewhere. I mean, It didn't start at Waterloo. It started back in high school, and even earlier. I was in a track and field program back in Kamloops, BC, and I had a coach there. You know, track and field being very different from basketball, very much an individual sport.
Yeah,
I had a coach there named Derek Evely, and he went on to coach the Canadian Olympic team, UK Olympic team in the future. He's coaching the small town, you know, Kamloops Children's Track and Field Club, and he's a guy who. Oh, can you hear me still? Sorry, I think my internet cut out for a second there.
No, that's okay. If it cuts out, you'll just come back. It's recording. Okay. It's recording your feed, so it'll
okay.
Well.
Yeah, sorry. So yeah, I was back in the Kamloops Track and Field Club. This coach went on to coach the Olympic team. I was coaching 8, 9, 10-year-olds, and just the way he would sort of expect the same out of us as he did later those Olympic athletes, I think really instilled a sense of responsibility and work ethic in us that sort of, I think, drifted outside of sports for me into my work life, my school academic life as well later on. But that translated through to Waterloo and everything that kind of followed there.
Yeah. So you played track, but I don't know, how long did you play basketball for then?
Yeah, ever since elementary school. Yeah.
Okay.
I was doing basketball camps as early as age 5, 6. My dad used to play with us, and then that kind of just like translated over into school, and then club teams, and finally college ball. Yeah.
But when you came to Waterloo, just because you stayed nanotech, right?
Yep, exactly.
Yeah, and so I mean, just being a student athlete was challenging in itself, but a program like that, I think it was fairly new program at the time. Am I right about that?
Yeah, we were the 4th or 5th cohort, and I think to your point, a really kind of interesting anecdote I like to tell is that leading up to Waterloo, you know, I wasn't recruited to go there. I was kind of a walk-on, last-minute decision to try to join the team.
Yeah.
And, you know, it worked out well. I had been told by most people leading up to it that, you know, you can't do both the intensive academics and the varsity athletics at the same time. Like, it's not going to work out well. And so I had my heart set more on, you know, dedicating myself to the academic program because I didn't have any aspirations of going to the MBA or anything like that.
Sure.
So I had to kind of think about my future. And then another mentor of mine, one of my old basketball coaches from high school, sent me this kind of long-winded, sort of poetic email. And he was always kind of an advocate and a voice of confidence for me. And he was just saying, like, you know, if you want to do it, you should just try it. This might be your last chance to play at like a high, you know, organized competitive level.
Yeah.
So I really took that to heart, and I went for it. And just to kind of cap off the anecdote, I mean, the interesting thing is that, as you know, we had a co-op program at Waterloo. So for anyone who doesn't know, that's just generally interspersed work with academic programs. So schoolwork, term on, term off. And what playing basketball meant was that I wasn't able to leave Waterloo for a lot of those work terms. So some would think that would be sort of restrictive. but it ultimately really forced me into doing some academic research on campus with some professors, some Ph.D. students who were there. And that in turn led to some publications, which I think ultimately got me into grad school. It was a very strong factor in that acceptance of mine down to grad school. So sort of like that little butterfly effect, you know, by playing basketball, not only does it instill that kind of focus and that, you know, that hard work ethic, but it also, I think, actually opened up a lot of opportunities for me at the same time. So I think my takeaway there was like, you want to think on the positive side and think about the doors that are going to open for you whenever you have to make these kind of tough decisions.
When you think about, or if there are newer student athletes entering that sort of space, what would your, I don't know if you reflected on that time, but like in terms of achieving balance or trying to excel during that period of trying to balance, you know, athletics with schooling, what would your advice or what's your thoughts on that?
I mean, I think really in life there's, I mean, this is drastically simplifying, but there's kind of three facets, at least in the college life as I saw it. There was, for me, athletics, academics, and then kind of the social and sort of personalized joy that you get out of life in general. And those things can overlap, and I think the message for someone considering being a student athlete in a tough program is just that you want to be able to find joy in all of those facets. And so if you're not loving the school, you're not loving the athletics every day, and it's inevitable it won't always be great, right? But you need to find people, you need to have people in those streams of your life that bring a lot of joy. So I had some really, a few, but really close friends in my academic program. So we were, hanging out every day, working on stuff together. That's critical, right? You can't be alone in your academics. I found that out in grad school later on. But then in basketball, had amazing people like you, had a lot of teammates, coaches who were really instrumental in, even though it's a grind, practicing every day, 2 hours a night, traveling every weekend. If you like the people you're with, I mean, it's cliche, but it's true, it makes it not nearly as difficult. So
was there a sacrifice that you felt like you were making though to find balance, and what would you say that sacrifice was?
Yeah, absolutely. So, part of it was social. I like to say that, and a lot of guys on the team were in tough programs, but not everybody, and people took some things less seriously than others, as you know, speaking of Sunday morning training sessions. But I think my sacrifices I saw was that, I wasn't the best basketball player I could be because I wasn't able to stay after practice for an hour and work on my free throws or, hit some shots or whatever, hit the gym extra times. I wasn't the best student I could be because I wasn't, studying on weekends all the time. I was off playing basketball. And so I think that's the main sacrifice, but at the same time, it worked out very well. And I think if you kind of embody the discipline that is required to do it, and then really enjoy the times when you have kind of free, which are sometimes few and far between, you can still eke out that aspect of relaxation at the same time, and it's a little bit sweeter even. So it's definitely, you got to know you're going to be sacrificing, but for me at least, it worked out, very well ultimately.
Did you play all 5 years or 4 years?
About 4.5, because I think this is after you had graduated.
Yeah.
But I went over to Europe for a co-op term.
Oh, okay.
For my final term. It was something I was really interested in doing. It was a sacrifice in that I left the team for half a year. It turned out to be Coach Kieswetter's last season. Didn't know this at the time, so I actually missed the last half season that he was coaching. And that was a tough decision, but I had kind of gone to Waterloo and really loving the idea of the co-op program. I really love international travel and kind of testing myself out in that sort of arena. So there was an opportunity to go spend 8 months in Austria and work over there, and it was tough to turn down. But
the interest in nanotech, you program, I imagine that in itself is a bit of a risk, right? People look at programs and established faculty and all that, but just what was the decision and what was the path that sort of led you into that field? And I guess even just after that, just describing to folks what the heck nanotech is.
Yeah.
Some people
I can start with that, and that's really what drew me in. I finished high school, graduated in 2007. I actually went down to Brazil for a year for an international exchange program. And so it was down there that I was kind of thinking about, I hadn't applied to any schools yet. I was thinking about universities. I didn't really know what I wanted to do. That's part of the reason why I went on exchange, which was a great experience. Definitely recommend that for anybody at kind of any stage of their development. And I was looking at programs and, I thought, okay, maybe I'll do chemistry, maybe I'll do biology. Every one was a bit too narrow for me. I was just kind of broadly interested in sciences and the environment and sustainability, which I'm sure we'll get to. And then nanotech it's really just, nano just means small, right? So it's small technology. And that doesn't really imply any sort of specific field. It kind of cross-cuts through, chemistry, chemical engineering, electrical engineering, physics, material science. So that was what I think was attractive, was sort of the broadness of it and sort of the applicability. The technology piece sort of applies or implies that you are not just studying things, but you're also building things and applying that material and technology to real-world applications. And we didn't get that far towards doing that in the undergraduate program, but I think it was a good primer to do that later on in life and in my career.
Yeah, very cool. And then didn't the nanotech building, wasn't it built in a really special way? I don't know. I mean, maybe I heard this from afar, but it was built so that there weren't any vibrations or something like. I don't know. I could be wrong.
That's true, and I'll tell you a quick story about that too, because I think it's a little funny. But exactly that. So they have to have special foundations. Either they do some kind of floating thing with some shock suspension absorption, or they have very heavy granite slabs that they kind of put down in the foundation to limit the vibration. Reason for that is when you're doing microscopy and looking at single atoms on the nanoscale, the smallest vibration of a truck going by 100 feet away can totally throw off that microscope. At the same time, when you're kind of fabricating these devices that are the transistors that we have in our phones and computers and electronics, we're talking about a 5 to 10 nanometer gap, which is the size of a molecule, basically. So when you're kind of building those things, they don't necessarily build those at the nano building, but getting close to doing that. So you really need that vibration isolation. But the funny thing about that is the day I went to visit Waterloo, before I decided to come with my parents, they had the groundbreaking ceremony for the nano building there.
Yeah.
And then for my whole 5 years that I was there, it was under construction, and that was my program, right? So we wanted to get in the building. We were excited. We were situated in the basement of some other dingy lecture hall, no windows for 4 years of lecture. You know how that goes in undergrad. And then finally in my last term, I think we had one class in the building, so we got our feet in the door. Then I came down to MIT. I won't get ahead of myself, but for grad school, I thought, they'll have all these great facilities already built. The exact same thing happened. The first year I was there, they broke ground for a new nano fabrication building. It was right beside my grad school office, and so it was jackhammers and digging for 4 or 5 years.
Yeah.
But now we actually work there for our company, so we'll get to that later. But I got my revenge there a little bit.
That's fine. Was Waterloo then ahead of its time, would you say?
Yeah, I think so. I mean, it's hard to say without having gone to all the campuses, but I think in a couple of ways. So I think the nano program, nanotechnology had been around for a long time already. It was sort of one of those things that's always it's the future, right? It's 10 years out. I mean, it's a bit of a misnomer because it just means pushing the limits of all scientific and engineering fields to the very small scale. So that's a constant, progression of doing that in all areas to gain advantages for specific reasons. But, so they kind of foresaw that, and I think the program was pretty progressive and advanced for what else was out there. And I think also the co-op program specifically was, I mean, you probably know this, they were one of the first co-op programs in the world, and I think still one of the largest in the world.
Yeah.
I mean, I would attribute that, as I mentioned before, doing some grad school level research, doing some kind of, I did some government work with Environment Canada my first term. I got to do some private work in industrial settings, and that was all really instrumental into what I later went on to do. So I'd recommend the co-op program to anybody. I think it's an amazing feature that Waterloo has to offer.
Yeah.
I think you participated in co-op as well, right?
I did, yeah. I did it through kinesiology, and I mean, kinesiology was more science-based at Waterloo, and so the opportunities probably might not be what people might think. You're not training with athletes, you're not doing a lot of physical stuff, but a lot of ergonomics was a big focus there. So yeah, it prepared me for having those job skills, interviews, all that sort of thing, which is valuable.
Very cool.
Yeah. As you said, with the nanotech, the applications of it are enormous. Why start to focus? You said you had a bit of this passion or interest in the environment and sustainability before even coming to Waterloo. You go to grad school, and I don't know, what was your focus at grad school then?
Yeah, I can tell that story. So first of all, it's kind of funny. I was pretty fixated on doing a master's at U of T or something, UBC back in BC where I'm from. And I was looking at all those options, talking to some professors, about their research, and had some offers to join some groups, different institutes around Canada. And then when I was in Austria, I was meeting up with some of my friends from Waterloo who were also on co-op in Europe, and we were doing some hiking and stuff. They were talking about writing this like GRE exam, which is the equivalent to the SAT, but for grad school. And I was like, why do you want to write that? No schools in Canada require it. And they were all applying to US grad schools. And I was thinking, I hadn't thought about it. I didn't think I was good enough to get in to, you only want to apply to some good ones. You don't want to apply to mediocre. There's lots of good schools in Canada, so there's no point going down otherwise. So I thought, okay, I guess maybe I should try that. And I applied to MIT, Berkeley, and Caltech, I think, because I Googled the top 5 or whatever just to see what I should apply to.
Yeah.
I only got into MIT. So it was a very easy decision. And I say only, but obviously one of the better ones. They're all great. So I didn't really have a tough decision. And then as soon as that happened, just decided to kind of come down. But I think your initial question was a bit different. So how did it work when I came down to MIT is what you're asking.
Yeah, I mean, how did understanding what that work of at MIT was, but then just the focus then particularly on sort of the environment and sustainability and all that.
Yeah, absolutely. So it's sort of one long sort of trajectory that's led to where I am today, and I will probably get through it. But when I first came down, I'd always been sort of passionate about two things. I think in sort of in my career path or kind of development. One was definitely kind of the science of thinking about things from sort of the atomic scale up. So how are materials actually arranged on the molecular level, the atomic level, and how does that affect their properties and application on the macro scale, that you and I interact with all the time and society interacts with. And the other piece was more kind of interest in the natural world, a lot of hiking, outdoor stuff, camping, snowboarding, biking, etc., climbing, and just really loved being outside. My parents took us out on a lot of camping trips as a kid, and obviously being very well aware of sort of the catastrophe that we're continuing to go through now. And so those two things merging, it kind of felt like a natural fit that I wanted to work on something in the sustainability or clean tech space. So clean technology, really sustainable energy kind of stuff. When I got to MIT in material science department, there's sort of like a period for the first few months where you're sort of speed dating with different professors that you could possibly work with. It's a bit different than Canada in that regard, where you already kind of have your professor set up before you arrive. And so a lot of people were doing great work in material science on solar cells, photovoltaics, batteries, which is still obviously a very hot area. And I kind of came back to that in a way. But to me, it had seemed like those spaces were sort of very populated already. So a lot of trusted people doing that great work. And, I don't think I was going to make much of a dent in it. And so looking around, there were some groups, including the one I ended up joining with a guy named Professor Jeffrey Grossman. And he was thinking about water filtration and different kind of filtration membranes for water purification. And that kind of struck me as, something that's obviously critical, for a lot of reasons around the world, for society and the environment. And something that not a lot of people are working on. I kind of had the inkling, when I told people I was going to work on this, they said, well, isn't that already a solved problem? And it's really not. We can talk about it as much as you'd like, but really developing new materials for membrane filtration to be more sustainable and more accessible for people, especially in the developing space, was like an early goal of that research. It didn't end up there, and I'll tell you how that evolved, but that really struck me as something that was relatively unique in the kind of academic research sphere, and also something that was very interesting to me at the same time. So very attractive.
You said that water filtration isn't very sustainable. Like, I guess are you talking about just normal like city utility kind of water filtration, or what are we talking about here?
Yeah, so when you think about water treatment, really the sort of state of the art is what's called a polymeric filtration membrane. So if you think about municipal water treatment in most municipalities, cities around the world that have that infrastructure, or a reverse osmosis desalination plant. You don't have a lot of those in Canada, but you have some in California and Florida, Australia, the hotter, more arid regions of the world. So there's a really good technology that has been developed over the course of 70, 75 years in polymeric membranes to remove salt from water. And actually, even in terms of the energy efficiency of that process, it's very, very strong. So if you think, a bit of a science thing here, excuse me, but
go for it.
if you think about, you have perfume floating around a room, or salt water floating around a big tank of water, or salt floating around a big tank of water, rather. the salt or perfume wants to be like dispersed. It's going to naturally disperse or diffuse around that container or the ocean, for instance. And if you want to, say, collect that salt or perfume back into a smaller region, you have to exert some energy to counteract that entropy that's causing that stuff to disperse around that container.
Yeah.
And so there's a minimum required energy anytime you want to do that. And so what's driving the minimum required energy to separate pure water from seawater, basically. And you're fighting a process called osmosis there, and that might be a term that people are familiar with. And polymeric membranes are very close to that minimum. They're like 5 or 10%, above the energetic minimum for separating salt from water. But that's not the main problem. The main problem is that they're also very fragile. So they clog, everyone's familiar with clogging of membranes probably, or similar media. They clog very easily. They're very hard to clean. They degrade and usually have to be replaced every 1 to 2 years, on average, depending on how much pre-treatment you do before the membrane. So typically you have 5 or 6 pre-treatment stages of this, even seawater, which is quite benign, coming into like 5 or 6 pre-treatment stages. So by the time you get to the reverse osmosis membrane, it's only salt and water. There's nothing else in there. Otherwise, you clog it up almost immediately. It would be pretty useless to use. So in that sense, they're efficient in the energetic and sort of techno-economic cost sense. But in terms of the usability or the viability and more demanding applications, they're not very good, across the board. So that's kind of what I mean by saying the situation is not ideal.
I want to step back for a second and go back to your time growing up in Kamloops. I mean, Kamloops is a place where, and you're going to describe with way more accuracy, but I mean, I always, we often go to road trips down to the mainland and off the coast there, but we would drive past and through Kamloops, and it's wildfire central, right? Like it's
pulp mill, wildfire.
Yeah. What was it like for you growing up? Like just around that? Like did you I imagine that you would notice this or even be a part. I mean, Kamloops had a serious wildfire, I think, like maybe more than 10 years ago.
I just drove by it. I was actually back visiting like 2 weeks ago, and I just drove by that kind of hillside where, it's a lot larger than that, but kind of where it came over the top of a hill towards the highway.
Yeah.
And the trees are all still like, matchsticks there. It's pretty impressive to see. I don't know if I described it. We definitely noticed the smoke. I think it's something, growing up in it, you kind of like, it's part of life. I don't know if I necessarily myself ascribed it to climate change at that point. I was just sort of a fact of life. But these days, down in the U.S., you hear a lot about California. The fires there have obviously been just horrific the last few years. Like a lot of people killed as well. So that really starts to turn heads in terms of like, once disasters, they always affect people, but once they start outright like causing loss of life directly, be it a hurricane or a tornado or a wildfire or drought, especially when it hits close to home, right? I think we as humans are really bad. I've had people ask me, like, so when is this climate change stuff going to affect us? And I'm like, well, it's been affecting us for decades. It's just not affecting, like, us. It's the people who are living in disadvantaged areas and disadvantaged populations around the world that have been dealing with this forever. And sadly, it gets worse for them before everybody else. So the fact that it's hitting home now, I don't know. I mean, I'm hopeful that it definitely puts a lens over the issue or a microscope over the issue, and I hope that results in more action. I mean, I'm not overly hopeful looking at politics these days. But
yeah. Do you think people are internalizing a little bit more? Like they're seeing that sort of, even if it's entirely directly, but they're seeing that linkage and because this has been a bit anecdotal, but like the recent storms in Atlantic Canada, for instance, I remember watching the news and people getting interviewed, and they're like, people weren't talking about climate change before, but our communities are talking about it. Like people see the links, but I don't know. What's your sense of that? You think people are internalizing a lot more?
Yeah, I think we are. I'm also a little concerned. Not sure what your sense is. I mean, my experience here and now is that life is getting harder and harder for a lot of people. In terms of like inflation, in terms of supply chain stuff. I mean, it's. I mentioned I have about a 1-year-old baby. I mean, there was a formula shortage here. There was like a baby Tylenol shortage, probably a little bit for you guys too.
Yeah.
When stuff like that happens, I mean, people tend to like focus in on the here and now and the me, rightfully so. And that's just human nature. And I think it's hard to trigger change on a level that has to be triggered without broad sweeping legislation. And so I think probably the most important thing we can do, if we really want to fight climate change, is to vote, for people who care about that and who are talking about taking big steps in that direction. Of course, we all want to do things like, drive EVs. It's important, and take the bus, not drive at all, eat sustainably and all that stuff. Very important. But I think that needs to happen. But even more importantly, we need to have legislators and governments who are actually going to act on this, because it's such a big problem that without that kind of response, it's a really tough thing to crack.
How long have you been living in the States now?
Since 2013.
Okay, so some time. So, you've seen obviously the change from Obama to Trump and now to Biden. But compared to like Canadian politics and American politics, like I don't know if do you follow and kind of participate in the political process in any way, but what's that like, or what would you say is the difference?
Yeah, to be honest, when I was in Canada, I was following more, the U.S. politics is a bit spicier, so it's sort of captivating in a bad way, and I haven't followed Canada too much. I talk to my friends and family still about what's going on. I try to vote absentee when I can and educate myself on the decision there. I think the U.S. has always been, a little bit more. There's been a little bit more kind of anger, I think, in general. But I see it in Canada now too, which is also all over the world. It's not a U.S. problem; it's like a human problem.
Yeah.
The U.S. is always kind of at the front and center of the global trends, right? So maybe that's part of it. I think it comes from. I'm not an expert. I think it comes from a root of people having a really tough time. There are places in the U.S. and Canada and everywhere else where, even though we're developed countries, like people are really, really struggling. Economically, socially. And there seems to be some sort of a vicious spiral there where that struggle creates animosity and fear and anger and pain, and then that kind of spirals down into more struggle and more animosity and more division.
Yeah.
So I've always been a fan of what Canada does in terms of the social safety net, and I think that my basic theory is that can help sort of stem the bleeding a little bit. Like if you have a social safety net in place, people won't be quite as angry, quite as scared, quite as fearing for their livelihoods, for instance, and their families. Yeah. So I think that helps, but it's a long, challenging process to put in place for a country like the U.S. of very diverse, of 350 million people. It's not no small task. So
do you find you live in Massachusetts, which is generally a liberal state, right?
Yes.
It's usually very democratic. But do you find that even there that there's a struggle in terms of what folks see there as sort of liberal and progressive versus what maybe part of Canada is also different. Alberta is very different than Ontario, of course, but or BC for that matter. But do you sense that difference when you're engaging with your colleagues and people around you, that their values are different? Or
I'd say Massachusetts is very similar to Canada. I think you've got a similar feel. Culturally there are some differences, but politically, I don't think too many. Just to give kind of a little bit of a backstory there. I've been to this down south quite a few times, like Texas, Georgia, Florida, and the difference between Canada and Massachusetts is zero compared to the difference between Massachusetts and those places.
Okay.
So it's like going to a different country. But I think what does permeate is sort of the feeling of it. So when you have different parties in power, for the previous 4 years. Where you just don't feel good about what's happening on a national stage. That sort of, I think there was a lot of weight on people, especially people who don't necessarily agree with those decisions and those directions politically. I think even though it's not necessarily happening here, and there's different kind of state protections here, they're stronger versus Canada, for instance, kind of more difference between states. There's still that air of a pall hanging over you, even though maybe it's not affecting you directly.
Yeah.
Because it's still your country, and you still want to feel like you're going in a good direction.
Yeah.
Just the squandered potential to me, of sometimes of Canada, sometimes of the U.S. How much we could get done if we actually were thinking, in my opinion, about the right things. It's sort of the wasted potential, the wasted resources, and the wasted fighting back and forth. I think it's very frustrating.
Being an entrepreneur in that kind of clean tech space, what do you think is the right role of government? Like, is it really getting I mean, Elon Musk has talked about this more recently, like with the Inflation Reduction Act that the Biden administration passed, and there was so much money that was thrown towards the support of like electric vehicles. And he's like, just stay out of there. I mean, like, you can interpret that in a number of different ways, right? Because I mean, Tesla's already has a huge market share. You know, maybe not, doesn't want the support of other companies to happen, but yeah, like what would you say, being right in the thick of it, right? What's the support that you would want to see from governments in terms of clean tech? Is it really staying it out? Is it kind of like a market based policy, like a carbon price, or like, yeah, what does that look like for you think?
Yeah, I mean, ideally, you can tell I'm pretty biased. I work in the space. I'm pretty into the environmental movement. Yeah. I, definitely a believer in climate change and all this. So my answer's gonna be different than some. But, I think if you look at what the government subsidizes now, it's a lot of fossil fuels. It's like, large scale farming, livestock, stuff that's like pretty bad for the environment. So it's not that they're only into clean tech, it's that they're subsidizing a lot of things. And ideally, if you did the analysis, which is almost impossible to do, what does subsidizing clean tech mean for like saving lives and saving livelihoods? Ultimately, it means a lot. Like, if you could equate dollars spent in clean tech towards like lives saved or lives improved or quality of life improved, I think that would be pretty stark. And you look at the other side, which is already happening, and subsidizing fossil fuels. And I'm not a person who's going to say that we shouldn't have any fossil fuels. I think that's a bit of a naive point of view. We all use them, we all need them. But I think squandering the potential we have to be developing and building out the renewable infrastructure, which we have at our fingertips, if we wanted it, is a very bad way to go. So to sum it up, I would say I think government really does need to be subsidizing these things. But I would also say, maybe to Elon Musk's point, maybe not. You never tell with that guy, but that, if you really want clean tech to be successful, and this is something we're trying to do right now, you have to make it not only sustainable, but also cost effective. So it has to be cheaper and also more sustainable. And then the market, there's no decision to be made. The market will adopt that technology. So that's what I think everyone strives for who is working on, new clean tech technologies. And it's a huge challenge. It's very difficult, and subsidies can help with that.
Well, de-risk that investment, right?
Cost-effective technologies.
Yeah. I would imagine, like, just starting out, like, those subsidies, like, de-risk, your investments in starting these ventures, right? So.
Totally, yeah. So, I mean, I started a company. Basically, the progression was I worked on this filtration technology. Developed it in my Ph.D. and then a short postdoc just a couple of years after the Ph.D. in the same lab group, and then co-founded this company, SiTration, with my previous professor, Jeffrey Grossman. He's a co-founder. And, what really got us off the ground was a few opportunities like that. We got some U.S. federal government funding from the Department of Energy and from the National Science Foundation, two of the major kind of funding foundations or funding centers for early clean tech research. And, without that, it would have been very difficult actually to raise, private venture capital funding, which we ended up ultimately doing because we were able to hire people with that initial grant money, basically. So really important for SiTration and a lot of other early, especially in the hard tech space, software, you can kind of start it up a little bit cheaper because you just need a computer and some people. But in hard tech, you need to spend millions of dollars to kind of set up the lab space. You're working with instruments, tools, a lot of materials and time. So it's important.
The focus of SiTration, let's talk about that now. Yeah. So comes out of your graduate work, start this company with this professor. What is the wicked problem that you're trying to solve here with SiTration?
Yeah, so let me just preface by saying that we didn't start out focused on this. I kind of mentioned that we were initially thinking about, and I'll get to this pretty quickly, but we were thinking about drinking water. We went into then like industrial wastewater, so oil and gas produced water. There's a big problem there. Still is. Textiles wastewater over in Southeast Asia is a huge issue for a lot of countries over there and people over there. So we did a lot of work there, mainly based on some funding we had during the grad school period. But pretty quickly realized, unfortunately, actually, that if you're treating, very large volumes of water, with very little value, monetary value. It's a very hard kind of first market to crack into because you still have to kind of try to make money, unfortunately, in the economy. So we started training our focus a bit more on applications where we still thought we had a unique sort of product market fit, where our technology would add unique value. It's very important, obviously, but also where, you know, the value of what we were doing was a lot higher economically. But that could still ideally have that impact because that was still important to us environmentally and societally. And so to get to your question, though, what we ended up coming across is that there's this massive issue that's kind of coming up in the next 5 or 10 years in society, which is the ability to recycle lithium-ion batteries. So primarily from electric vehicles, as you probably are aware, and others in electronic devices. But electric vehicles are by far, you know, much larger batteries. And right now there's no good way to recycle those, but around 2028, 2030, we're going to get our huge kind of first wave of, you know, end-of-life dead electric vehicle batteries coming in. And there's really no good way to both sustainably and cheaply recycle those to reclaim things like lithium, cobalt, and nickel from those end-of-life, you know, battery units. Now, there is a way currently, and I can go through that if it's interesting, but what we're proposing to do is to drastically kind of shift the paradigm there to a process that is much more efficient, much lower cost, and much more sustainable as we need to start recycling more and more of those batteries.
So how does, because I think, isn't there a lot of like smelting involved right now with
Yes.
Okay, maybe tell people how, because I think that is a concern for people, right? And I mean, I think people are skeptical about EVs or solar or whatever. Sometimes the skeptics come about, the conversation focuses on like, okay, this is great, but what happens with the solar panels? What happens with the batteries? And it's like, oh, you're just pushing that problem you know, further down the road. Fair point, of course.
And they're not. It's not wrong, right?
No, it's not wrong.
It's a true thing, you know. And I would say, like, I'll get to how we do it today. I mean, 80% of the world's cobalt comes from the Congo. And that's produced using, you know, unacceptable humanitarian, you know, child labor, maybe even slave labor in some cases, and, you know, very poor environmental practices. So there's a point to be made there. I think typically when you think about, you know, the offset of, you know, burning fossil fuels, it's kind of a global issue. And when you're, you know, mining critical materials, it becomes more of a localized issue and a geopolitical issue. So neither is better or worse than the other. The scales might be different, I think, but it is a fair point. I mean, we want to mitigate these impacts in any case as much as we can, and that's a big part of what SiTration is trying to accomplish. I mean, if we can actually recycle these things that are already in batteries, we don't have to extract as much. I mean, I'm not saying we're going to replace mining ever, but we can sort of mitigate the amount of kind of accelerated mining that has to be performed in the next few decades. So the way the recycling works today, there's really two main processes you can use. So one is called pyrometallurgical recycling, and so the pyro infers there the kind of the blast furnace, the smelting aspect. And so they just take the battery, and the interesting thing about lithium-ion batteries is they're very dangerous. Even when they're like dead or end of life, they still contain a lot of energy in the materials themselves, and those materials can be explosive. They can burst into flames spontaneously, and so in the pyrometallurgical route, you don't care. You throw that whole battery into a furnace and just burn everything, and that sort of diffuses the hazardous, you know, risk there. And it also, but the problem is it also burns off a lot of the byproducts. So things like lithium are often burned off into the waste. And so historically, lithium was not needed to be recovered, but now the price is going up quite quickly, so it's of interest now. But you smelt down into like a slag, essentially, the cobalt and the nickel, and the other metals, cobalt, aluminum, etc., which are of value. And so then you dissolve that slag into an acid, typically, and you can do chemical
slag,
reactions.
just like a hard, like something, just like a
molten mass of metal. From
that
like high temperature furnace.
And
you dissolve that down into an acid, typically, and do then what's called a hydrometallurgical route. And hydro refers to kind of an aqueous or water-based chemistry. So you use acid, you dissolve the metal, and then you kind of slowly pick out all the contaminants one by one by adding certain chemicals and adding heat, creating kind of sequential reactions to ultimately purify the cobalt and nickel back into the pure form. So that, you know, it works. People do it. It's been around for, you know, many decades. The other route that's gaining more popularity, and actually is developed straight from the mining industry, it's been used there for a long time, is strictly a hydrometallurgical process. So I already mentioned that word in the context of the pyro route. But in hydromet or hydrometallurgical processing, you don't ever use the blast furnace. You kind of shred up the battery, mechanically. That's also kind of a thing of art, because you can't, you have to shred it underwater in inert gas so it doesn't explode. So you shred it up mechanically, you kind of release all of that chemical energy that way. And then you get a fine powder from that shredding. And that's then dissolved in acid, and you go through a similar process to extract everything. So, it can be done. You can extract everything. The efficiency is low. It might be 35 steps to get to, the final products. And it's quite costly and non-sustainable. So what SiTration is doing, the real paradigm shift here, is we have this membrane technology, which doesn't seem to really apply to this process. What we're able to do is actually put it directly into that really acidic solution right after that powder is dumped into the acid. So with no other treatment, we can drop our membrane in there. We actually, because the membrane is made of silicon, hence like the SiTration, silicon filtration, we can run an electric current through the membrane. What that electric current allows us to do, and this is unusual for membrane filters, they're not usually electronically conductive.
Okay.
So what that allows us to do is now play around with materials like lithium, like cobalt, like nickel, from this incredibly, harsh acidic mixture that's very complex, but pull certain things out, like those most valuable materials, with very high selectivity. What I mean by selectivity is just that we can say pull out lithium and leave everything else in with a very successful rate of that kind of separation, if you will.
So you'd still have to work, though, with these other processes to get it to that powder, right?
Yeah, you'd have to grind up the battery, yeah. So, there are other routes that people are exploring that wouldn't be too applicable to what we're doing, called direct recycling. And so there, the aim is to sort of disassemble the battery more carefully, sort of keep some of those materials together in the same proportion, and then sort of recycle them, or rejuvenate them and recycle them, or reuse them, kind of without stripping them all the way down to the most basic level of the elements or compounds themselves in pure form. Now, that could be really interesting. I think there's a place for that. The challenge there, though, is if you think about, all the different vehicle companies and battery companies, they're all producing slightly different battery chemistries. And so it's quite difficult then to kind of maintain a certain chemistry from a given end-of-life battery and put it back into a different battery. It just won't work that way. So our kind of take is that could be useful, but we're also going to need to do, recycle things all the way back to their most basic form, their purest form, to start from the beginning as well.
Yeah, I don't know if this might sound like a silly question, but when it gets down to its purest form, is there a quality issue there, compared to when you get the purest form of cobalt, nickel, or lithium from a mining process versus recycled versions of this? Is there any difference there in the quality?
No, it's a really important question, actually. So the battery manufacturers need, ultra high purity, because batteries are such a sensitive technology and device. Any kind of minute difference can throw off the performance over a long period of time. And so the question is really important. And so if you think about sort of a atom or a compound of material, it's all the same at the atomic scale or the molecular scale. It's just about the purity, to your point, how much contamination is in there. And so whether you're getting that, compound or material from the ground via mining or from a dead battery, you can bring both of those things back to the same purity. Now, the question is how much effort, how much cost, and how many resources are required to do that. And typically, the nice thing about battery recycling, if you think about, grabbing out lithium carbonate or lithium hydroxide or cobalt or nickel from the ore in the ground, there are probably, 50 or 70 different, materials that are co-inhabiting that sort of ore. So it's actually a tougher separation process in some cases to isolate those things. In a battery, you do have variability, like I kind of just mentioned, but the list of elements that are in a battery are probably 10 or 12. And you usually know what they are. Maybe there's a range of composition or ratios, but you usually know what the kind of products are that you're dealing with. And so it's actually, I think, in my mind, maybe I'm a bit biased, I don't know as much about the mining space as I do about battery recycling, but it's a little bit easier to develop a process to reclaim those materials in high purity form. The other piece is that they're often more concentrated in a battery. So what's already happened is you've mined it from the ground, you've refined it, you've concentrated it, you put it in a battery. It's still concentrated when the battery reaches end of life in that kind of confined package. So in some sense, it might actually be easier to get back to the original purity that's required.
That's very interesting. With the pyro method, the I guess the emissions that come out of that smelting process, like, is it just dirty stuff, or
Yeah, I mean, it's definitely dirty. I mean, there's a lot of energy input requirement. I think that's the main downfall. The kind of off gassing of that, it really depends on how you're running your process. Again, I'm not an expert, but there are ways to like scrub all the contaminants out of that before you put it out into the environment. Depending on whether that's done, you probably varies to what extent by operator. So there are ways to make it relatively clean, but the energy consumption is relatively high, and I think one downside there is it's harder to recover things like lithium because they're burning off in the pyro process, basically.
Yeah. Can your technology be applied for? I don't know if you know. I know there's a few companies in Alberta that are taking the wastewater brine from oil and gas production, and then they're filtering out, lithium out of that. Or can you imagine could your technology fit into those kind of solutions, or not really?
Yeah, very, very possibly. So I know there's one called like Summit Nanotechnology. I'm not sure if that's what you're talking about, but they're a really cool company working on lithium extraction. Yeah. I think based in Alberta as well. I've connected with them.
There's E3 Metals, I think, is another one.
Oh, yeah. I've heard of that name. I haven't connected personally, but yeah, so definitely. I mean, anytime you have a kind of a challenging mixture where you have some kind of valuable material in there, we could probably be applicable. The SiTration technology, there are a lot of technologies, to your point, that are doing this kind of thing. And so when you have and this is like a more general message to all those aspiring entrepreneurial material scientists out there, when you have what you think is a unique material or technology, that very well could be the case. But what will really tell you if there's value is finding if it has unique fit somewhere, right? So if you can go out in an application and see sort of a path to creating more value in an existing, application industrially or societally, or if you're selling to customers like you and me, and that's a bit of a different question. But so we looked at that kind of thing. It may still be interesting, but we have to develop a little bit further than what we've gone so far in some technical areas. And I think we settled on battery recycling because the conditions, the environment being so harsh, being that pH1 acidic, leachate environment when you dissolve that battery powder into that. And because we can kind of withstand that environment, we can then drastically reduce the number of steps from, say, 35 to 5 to 10 steps to reclaim the same thing for less resources. And that's like really the main differentiating factor for us. We might be able to do something like sort of similar in, say, the oil and gas wastewater cleanup effort in Alberta and elsewhere, but I don't think the difference is as stark, I would say. And so the competitive advantage is less. So you kind of want to start where you have the largest competitive advantage and then sort of work your way down the chain, value versus effort over time, basically.
Yeah. That advice is very valuable, about saying that you might have this incredible material that you've developed, but you got to make sure it fits within some sort of applicable ecosystem that either already exists or is being used widely. Was that a hard lesson for you to learn, or did you kind of know that, okay, this is where I want to apply this membrane technology into this part of the battery recycling process?
Yeah, I think very difficult. It's still an ongoing struggle. Where we are today is far from commercial viability, far from being a product. We're still on what we call the benchtop scale. Okay. So we're operating on kind of the liter scale, right? We need to get up to ultimately like the ton scale to be in the commercial space. So, and I can talk about it if it's interesting, but there's this progression where you kind of demonstrate something on the benchtop, and then you raise more money to do it on like the refrigerator scale, then you raise more money to go onto the semi-truck scale. There's sort of that progression that's kind of built into the clean tech or hard tech sort of space. But the answer to your question, though, is definitely difficult. I mean, I was involved in a number of programs for academic people to kind of learn to be entrepreneurs a little bit before they made too many mistakes, before they raised too much money and wasted it all. Yeah. But one term I like to use, I didn't invent this, but it's a good term, is that most people coming out of a Ph.D. or academic work who have developed this like very early stage technology you basically have a hammer and you're looking for the right nail to hit. So the hammer is sort of predefined by what you've developed, and there's a million nails out there which are all representative of industrial applications, and for the most part where you could possibly be the best hammer to hit that nail. but you spend a lot of time like tapping around to try to find it. Typically, the more efficient way to start a company is you have this nail that you know you want to hit, and then you go think about how to develop the right hammer. But by virtue of just life being as it is, that's not my situation. And so we want to have an impact with that hammer, but picking the right nail at an early stage is really important. And a lot of what I was talking about in terms of like probing different markets, industrial wastewater, we looked at the semiconductor space, the pharmaceutical manufacturing space, the food and beverage or nutraceutical space, petrochemical production. The really important thing I would say is critical for anyone thinking about starting something real is before you do anything, like go talk to the people who you are hypothesizing will maybe buy your product or work with you, because you really don't know what they want until you ask them. And I went through a whole bunch of programs that kind of trained you to do this and not to make assumptions and not even to bias those conversations. It's not like if you're an expert in, kinesiology, I don't come to you and say, would you want to use a knee brace that can like make people jump 10 times higher? I come to you and say like, Pesh, tell me about your day in the life of what you do. And, talk to me about what upsets you and what you wish would be better in your day-to-day life. It's only when you do that in a non-biased way can you really pick out, what's actually needed in your life as a kinesiologist or in any other field that you're in. And that's what we were kind of trained to do, before spending $1 million to develop a product that is actually useless to anybody. So,
going through this, like being this kind of entrepreneur in this field that you're taking on, a lot of risk, a lot of uncertainty, I would imagine. Like, were there times where you're just like, why am I doing this? Like, I should just kind of I can use my skills, my training and somewhere else that's already established and probably get paid really, really well. Like, did you have those doubts or did you kind of already always have this sort of entrepreneurial mindset of wanting to take on this wicked problem? Or, was that developed? Like, tell me about that.
It's a good question. I've thought about it a lot. For me, it's weird. It seems like the easiest path of least resistance. And I think part of that is like, it's sort of familiar. Like I went to grad school, I developed this technology. It's all kind of a progression. So it's never like a leap into something totally new, totally unfamiliar. A lot of what I'm developing personally is very different for me and out of my comfort zone, which I think is something I've always pushed myself to do. I don't know why or why I really enjoy doing that, but just like basketball Waterloo was out of my comfort zone, and so was the academic program and all of that. But it is a lot of fun. I think the uncertainty, it's a good environment these days. I don't think I would have done this had I been in an environment or a community that did not support this or where it was not sort of common. I saw a lot of good examples. Some of my lab mates in my grad school research group actually started a company about 2 years before me who were close friends. And so I saw that I was fortunate to be in a place where I had a lot of mentors and a lot of good examples that showed that it was not only like possible, but that it was actually a really good way to go. And the risk is certainly there. I mean, I think a lot of us who are doing this are kind of pulling the wool over our own eyes a little bit because we're sort of refusing to think about the likelihood of stuff not succeeding. And nowadays, the good thing is it's not cast. If you say you can definitely fail, but it's not necessarily cast as a bad thing. Depends how you fail. If you fail in like a good way, you gave it your all and you built a team and you tried to develop this technology. It would be a terrible feeling for that to happen. It would be, you'd have to let your team go and all of that. It would be the worst thing ever. But ultimately, it's looked upon as a learning experience. And so I think that culture of positivity around trying something new, pushing the envelope, going for it, and the support that comes with it. Because like it used to be that you would have to bootstrap everything, right? Like you'd have to go without a salary for years and like your family would be starving and all those kind of horror stories. Which I think people take like a weird pride in as well, which is a totally different question. But nowadays, I was fortunate in the Waterloo community. I think it's really great there now as well, especially in the MIT community and the broader kind of Boston area. There are, 1 million programs to provide funding, to provide mentorship, networking connections to other investors and stakeholders. And so it hasn't really felt that risky, to be honest. I'm also very fortunate. My wife has a great job, so we're very stable. So the biggest risk I think to me personally is like the possibility of failure or not having the company be successful. And that's like, that would be crushing, but at least it's not like a existential risk. Right?
Yeah. Tell me about, I don't know, how many staff do you have in your company?
Yeah, so right now, including myself, we're 5 full time.
Yeah.
We're actually just interviewing for another, and we have a guy coming on in May who we hired
Nice.
about a month ago. So that'll be 7 full time as of May. And then we try to do the same thing that I did as a co-op student. We try to hire a lot of co-ops.
Nice.
It's harder from Waterloo because they're Canadian,
Yeah.
and then with the immigration stuff,
Yeah.
it's tough. But
Yeah.
we actually have one from Waterloo right now who's a U.S. citizen, so that's pretty cool. And then we have a bunch from a school called Northeastern, which is based in downtown Boston. And they have a similar kind of 5-year co-op program to Waterloo.
Yeah.
So we have usually 4 or 5 kind of full-time interns. So that puts us around 10, employees day to day.
So you're leading people, right? Like, I don't know
Try.
if that, I don't, well, you are, right? I mean, I don't know if that was something you ever saw for yourself, but, you're in it now. Like, what would you, what's your approach to leadership look like? Is that something you take, like, is that something you study? Is that something you, like, tell me about that, because, I mean, some people take it really seriously, some people not so much, and they're just focused on the work, but I don't understand how that is possible. I think that when you're working with people, you need to focus on people, and you need to be a people-centered leader. But anyways, I'm curious about you, though.
Yeah, I mean, there's a whole spectrum of leadership, styles and abilities, and I'm very new. I mean, I do think sports was helpful. So, like, playing in team sports, I was never like a great captain of the basketball team, but that was, at least you have some responsibility to try to lead people to some extent. This is different because I'm all by myself kind of doing it for the most part. And I think the hardest part about it is that, like, I have a lot of different hats I have to wear in the company. And so I'd love to spend like all my time, leading the team and like working with the team, not even just leading, but like being with the team and getting their perspective. I mean, I think the style, I'm still very much learning at this, but I think the style I'm trying to embody is one where I'm really empowering people and listening to people a lot. Also, you have to sometimes delegate, right? If you're a team where there's no leadership, that's bad. But I think a team where people don't know why they're doing what they're doing, they're just being told to do things, I think they lose passion and motivation really quickly. So, like, all the passion I have for what we're doing that I communicated and, like, the reasons why I have that, I want to share a big part of that with the team and make sure that they're also excited about what we're doing. And I think another big, really important piece is to hire, get really good people on the team. I mean, that makes it a lot easier.
Yeah.
When you're not trying to put out fires all the time. I mean, we definitely have, conflict in a relatively healthy way and friction, and people have different opinions. I think that's actually really good that people feel empowered to share that. If everyone was just like kind of doing what I said they should do and not, expressing their own opinion or perspective, I think that's when you can get in a bit of trouble. And we've seen a lot of these kind of startups where they kind of go, Theranos is an example where the CEO is just like, what I say goes, and we're going to just do what I say, and we don't need to worry about facts or anyone else's opinion. I think that's an extreme example, but it can go pretty badly. So, I mean, I think really trying to empower people and sort of lead by committee to some extent, while still also kind of delegating at the same time.
I don't want to mischaracterize your company and your business, but I'm just wondering about the challenge of, like, you're the founder of this company. You're the one who brings the focus is really on this particular technology and this membrane, and you're trying to ensure that you empower your team through this process. But, like, you're the guy who came up with this thing, right? This product, this technology. Maybe the business expands into other areas. I don't know. How do you deal with that struggle? Because I don't know if you see it, but I would imagine, like, your staff, that maybe there could be people who would be like, well, I'd like to apply this expertise, but I mean, Brendan's the guy who created this thing, right? Like, how do they, what's the challenge there for them and for you to ensure that their voices are heard but also, like, that they understand that, like, you're so heavily invested in this because this is the thing you created. Yeah,
I mean, I think it comes through in my, like, the amount of time I spend and effort and intensity in which I, like, throw myself into it. I think they get that feeling, but at the same time, as much as you're the guy and maybe you just kind of started things out, it's really important to kind of shed that pretty quickly and be like, maybe I conceived of this initially and worked on it for 5 or 6 years before we all got together, but I'm nothing without a team, right? Like, I tried to do this for the first, like, half year of the company, and it's impossible to run everything at once. And so I think the way you kind of shed that sort of aura within the team is to give a lot of responsibility and place a lot of trust in team members and a lot of confidence in them. And, you're always trying to kind of share the way you think about things, but you also don't want to pollute their kind of perspective too much, because I've been in this for 10 years working with this like very specific technology. I'm pretty biased in certain ways. Like I have a lot of blinders on as well, because I've kind of conceived of it in a certain way for so long. And so even someone who comes as like a co-op student from, third year of university can definitely contribute a perspective that I haven't thought about, And a lot of times I know the answer to the questions, but sometimes I'm thinking, wow, like I've never thought about it that way. There's probably a lot of merit to that kind of perspective. And so, everyone on the team contributes something that's very important. I try to like make that very obvious and solicit a lot of opinions from people regardless of the stage of the career that they're at.
Was that something that you had to gradually adopt, like just that shedding and letting go of things, or did you understand that you thought that like everyone has value in the process, I don't always know everything, like, or did that sort of humility and shedding sort of happen over time?
I mean, I think you kind of know it from a factual perspective, but then to actually let go, I mean, it's easy to try to inspire someone to have, passion for what they're doing. I think what's really hard is to say, like, here's a big chunk of work that's really important for the company, like critical mission critical pathway here. I don't have a lot of bandwidth. I need to delegate this to someone else, and they have to own this. And there's a lot of stress related with that, because that a lot of times can be fundamentally connected to the success or failure of the company in at least a small way, or sometimes a bigger way. And the team is great and they're capable of it, but I think you really only know if you're capable of doing it once there's a really important thing and you're able to let that go. And I wouldn't say I'm not great at that yet. And as a result, my bandwidth I'm always quite overwhelmed, because I'm trying to like shoulder all that stuff, but really I should be offloading it onto the really capable team members as well. So I've made small strides, but a long way to go there as well.
Yeah. I want to end up on balance, but I don't know if you heard this. We've talked about Elon Musk before, but I would love to have witnessed that time. I don't know if you heard about him talking when the Model 3, when they were trying to ramp up production, and he said there was a mission critical point for Tesla where he's like, if we didn't deliver by a certain time, like Tesla would have went under. And, there's stories of him sleeping on the shop floor and being there all night, all hours of the night, that sort of thing. It would have been amazing to kind of, from a leadership perspective, watch that, right? Like how he would have interacted with his team, whether that was disengaging for the team or whether that was empowering, and what that level of involvement actually was. But yeah, when I heard those stories, it was just like, this is a great sort of leadership study case, what to do, because I also wonder about like what the lasting effects of that have been, right? Because you hear stories about how he's so tough on his employees, but I mean, unless you actually work there, no, I'm not sure what the culture actually is, but
I mean, it's such an interesting question, right? Like, are leaders do they get their best results when they're sort of a little bit crazy? Like, if you're the craziest one there and you're sleeping on the floor of your office, is that good in the long run? If he wasn't that crazy, would they be in that position anyway? Or maybe they wouldn't have been there if if that wasn't the culture. So it's hard to say. I mean, for me, certainly that's not my style. I can't do that. I can't operate that way personally, mentally, physically, and family-wise. I also think, if you're doing that as the boss, actually nowadays I see a lot of successful startups going the other way. Like the bosses try to take vacation, 3-4 weeks a year to convince the employees they should also take vacation, because I'm sure you're privy to this as well in your job. Like the culture of work we have now in North America is one that is, I think really detrimental to mental health, to physical health, to family life. So I think almost pushing back against that a bit more. There are sprints that you have to do to make progress, especially when it's badly needed. But, you want to limit those as much as possible. I think you don't want to have your employees living in a world where people have to sleep in the office, I don't think. But then again, sometimes maybe you do. I don't know. Yeah. So it's hindsight's 2020, but yeah, so that worked out well for them in that case.
Yeah. It gives me a lot of pleasure to know that you're a relatively new dad, and you've got a baby girl who's just turned 1, and so I remember, and I'm sure you do, and folks wouldn't know this, but you helped me out with my proposal to Michelle, and you lit a bunch of candles, and I'll never forget that.
I was thinking about that right before this.
That you support. I was talking to Michelle about this. That I don't remember if we even crossed paths before you lit those candles, and when I came down to my basement apartment. I hope there was a bit of crossover because there were a lot of candles lit, and that would have been a bad scenario. But it gives me a lot of pleasure.
I think we I didn't want to distract you because you were on your game, but I think I said you got this or something like that. I think we did rub shoulders. I think I waited till you were coming in and I was going out.
Thank God that happened because I'm like that would have been not good. But anyways, yeah, it was. I'm glad that you're part of that moment. So I'll always appreciate that. But just so much joy to know that you have a baby girl and you're running this company, and I mean it's great to know that your partner has a stable job. But tell me about what it's been like to be a dad and just sort of work-life balance and how you're trying to manage that.
Yeah, really, really challenging. I mean, I'm sure all parents go through this to some extent. It's not exclusive to parents either. People who have demanding work generally. I mean, but once you have that kid, I think it's sort of a bit of a wake-up call for kids. The first one probably is the most so. Wake-up call that you really want to be around, and you really don't want to be, sleeping on the floor of your office or what have you. Sadly, when when it's a partnership, and you're both doing that, it sort of feels a little bit more acceptable sometimes because you're both grinding, and that's, like I said, the work culture in North America here. But then the kid comes, and the kid's not grinding, right? They're there and they need you all the time. So I think it's a great wake-up call. The other thing I would say, obviously a lot of joy, and a great thing about it too, if I'm speaking selfishly, is that it's sort of a meditative thing. I've always enjoyed, and maybe a lot of people are the same way, doing things. I'm not a musical person, but playing music, for me, it's doing sports, working out, yoga, running, whatever, to really, or woodwork, really focusing in on something. It doesn't really matter what it is. It's not your work and not day-to-day grind, to really get you in that zone and meditate in a way, whether it's traditional meditation or just doing something that's super focusing. And I think it's the same with a baby. You're fully in the moment, you're dedicated to being there for them. You're interacting with them, trying to kind of hang on their every action and movement and sound. And that, I think, is actually, despite being very physically tiring and sometimes sleep draining, obviously, I think it's really mentally rejuvenating because you get that 100% focus when you're with your kid or kids, and that helps a lot. And it also you go back to the team at work and you're I think a little bit more confident in yourself because I'm taking care of a baby, so I can take care of these
I can do this.
25 or 30-year-olds, no problem, who at least sometimes listen to reason and logic. So. I think a lot of great things. Obviously it places more demands on your time and your sleep and your resources, but yeah, it's been pretty awesome overall.
Yeah, cool. Shall we end up on these last 2 questions that I asked every guest? Would that be okay?
Yeah. So I forget the one, but I remember the other one. So go ahead and what order you want.
So first question is our 5 for dinner question. Dead or alive, who are 5 people you'd have dinner with? And curious if you'd have them together or individually.
Yeah, so that's it's interesting. I mean, mine are weird, but I thought since you did provide the question in advance, I did look at it because I know it'd be hard for me to answer on the spot. But I think the one would be my grandmother, my mother's side. So she's not around anymore, but she was always a really strong figure to me. And her and my grandpa actually started their own company way back in the day, an import-export company down at the border in Vancouver there. So I always thought she was a super interesting person to talk to, and it would be cool to talk to her these days now that I'm doing what I'm doing with a family and all that. You
met her though? You got to spend time?
Oh yeah. She passed away when I was right when I was graduating college actually. But she was a little sick for a while, so kind of inhibited, I would say. I would love to meet her in her kind of prime. I think it would have been great. So that's definitely the first one. The others were hard. I mean, there's a lot of historical figures that I find really interesting. I'm reading some biographies lately. I think Ernest Shackleton is a really interesting one to me.
I don't know who that is.
So he was the guy exploring the South Pole, among
Okay.
other areas. Definitely a book I recommend. It's called Endurance. That's the story of him and his crew. Really quick synopsis. He's probably the most inspirational leader I've ever read about. And basically, he was an entrepreneur too. He had to pitch to all these people to get the funding to take an expedition down to the South Pole. They were going to sail all the way down there, and then they're going to get on dog sleds and dog sled to the South Pole and plant a stake there. And they basically got to the shore of the South Pole and got stuck in the ice with their ship. And the ship was crushed in the ice, and so they had to abandon, and it sunk. And they had to abandon the ship with everything they could carry in the South Pole in the winter, and basically push their little rowboats across the ice. And they had some dogs, and they would fish and try to kill. Well, there's no polar bears down there, but penguins and stuff. And for I think it took a year and a half. They were down there, and they eventually made it to the tip of one of the capes down there, and they set out in a rowboat across the tip of the South Pole to this whaling island, and every single man of that expedition survived.
Wow.
And just reading the story and every single thing that happened to them. You talk about the Tesla thing. If they didn't do this, then they weren't going to survive. They had 20 of these things happen, and every time they kind of pulled through. So that's a really inspirational leadership story of just never-ending endurance and optimism. So the book is called Endurance.
I gotta look at it.
Yeah. So I was thinking other people, always been interested in Winston Churchill and Abraham Lincoln, kind of historical figures that overcame a lot. So kind of reading some stuff on them, which is interesting. That'd be pretty boring dinner though with those guys, old white dudes. So I was thinking Robin Williams would be interesting. Michelle Obama is one I thought about being really interesting.
Yeah.
She's a cultural icon of the time and has totally transformed the way we think about all types of people, which is great.
Yeah.
And example setter. And then Jerry Seinfeld's always someone I think he's amazing. He's my favorite show. So that kind of combination. I think I named more than 5, but
that's okay. It's
that
party,
group,
man.
I think. Not sure how they would do together.
Yeah.
But certainly maybe together, maybe separate.
Yeah. Yeah, Churchill and Lincoln, though, I mean, I think Churchill was an eccentric figure, right? And Lincoln, I think he was fairly quiet, I think my understanding was.
Yeah, I know less about him, but just what he managed to achieve, I think, was I've always been interested in people who've managed to achieve, just amazing things in the face of great challenge, whether that's a physical accomplishment or, the kinds of divisions or, I guess wars in some cases these people were able to overcome. Always impressed me. So trying to kind of learn from those kinds of accomplishments and apply them to my own. I mean, I'm never going to have to face anything like those people faced, but I think there are a lot of lessons and inspirations we can draw from that.
Have you been to DC before?
No, I've never been, which is crazy. My wife has some family there.
Okay. I went on a school trip a long time ago and had this amazing experience where I was out with some friends there. It was around 11 or 12 at night, and it was super quiet across the National Mall and into where the Lincoln statue was. And we just sat on the top steps in front of Lincoln behind us and looking out at the Capitol. And it was just so quiet. And I remember having that feeling okay, I can feel the power of the United States. They've really set that place up in such a way where you feel the magnitude, the power of that place. But yeah, just to have Lincoln behind you looking over, I'll never forget that moment. Yeah, it was amazing.
Yeah, it's something super special. That's where I get to back to what I said earlier, the potential of the country, the U.S. is it's unlimited. In some cases, I'm I wish we could be using that in different ways, but. Yeah, the history and the weight of it is really immense. So I'm hoping. I can't believe I've never gone there. I'm not that far away. So someday soon I will.
Yeah, for sure. Last question. Besides the circle of life, what do you know for sure?
Oh yeah, this question. I didn't get to think about this one. I really believe in the power of humanity to kind of overcome. Since we're on this sustainability, climate change, remediation kind of stuff. I mean. Obviously, a lot of suffering happening, but I'm actually very optimistic about the power of society and humanity to figure out a way that we can make this stuff work, and that both applies to the environmental climate stuff, but also just I think making the world a better place in general for people to be in. And it's not free of suffering, certainly, but I see there's a lot of negativity out there, and I think rightfully so these days. But at the same time, I'm also optimistic. I see a lot of work that's being done, and one example is nuclear fusion. You're seeing progress being made there. It's still early, but stuff like that could be a total game changer. And so I think there's a lot of good stuff to come. I just hope it kind of outweighs the bad.
For sure. I love that. Brendan, man, it's been really good talking to you, really good catching up. Super proud of you. I got to witness the early part of your journey, not maybe from the academic side, but just your approach to how you took basketball seriously and the training, and I can see that translating into the way you described your path and into your work. And so just really proud of you, and glad that we were able to connect today, and I wish you nothing but the best in your endeavors and your company, and what an incredible problem to try to solve, and I'm sure you're going to be a part of other big problems that we need to solve. So just appreciate your time today, and just thanks for joining me on the show.
Yeah, very much likewise. I mean, obviously very proud of you as well. I'm really happy that we're staying in touch here, and I think the only thing we missed tonight is a beer that we're sharing between us. So next time I'm in Edmonton or you're in Boston, just let me know. And
I'd love to come down to Boston, man. I've never been that part of the States, and for sure.
Yeah, well, you've got a room to stay in, so anytime you want to come down.
Okay, well, thanks so much, Brendan, and thanks to everyone who's been listening today, and subscribe and stay tuned for the next one. And we'll see you later. Brendan, just stick around. Got to keep talking to you for a little bit.
Yep.
All right. Thanks, everyone. See you later.